Hello, and welcome to Vlogcast 3.6, Derivation of Inverse Trigonometric Functions. We're going to work on how to derive the derivative of the three inverse trig functions, arcsine, arccosine, and arctangent. We will first review the derivatives of the trig functions. The derivative of sin x is equal to cosine x. The derivative of cosine x is equal to negative sine x. And likewise, tangent x will become secant squared x. We will be reviewing the inverse trig functions and their definitions. Take a look at it. Now let's put this aside and focus on the function arcsine of x. If y equals arcsine of x, then x is equal to sine y, as shown in the presentation. So we can just differentiate x equals sine y, if it shows up, and implicitly differentiate to get dy dx, which is what we are trying to get. Now, Tomi will tell us the step-by-step tutorial to a derivation of y equals arcsine of x.
So starting off with arcsine of x, this expression really means y equals arcsine of x. So we're going to start off by turning this into a form that we already know how to derive, which in this case means that we will switch the x and y values and undo the inverse function, turn it into a standard trigonometric function. Now we have x equals sine y. Then we'll implicitly derive. So we'll take the derivative of both sides in terms of dx. So dx over dx equals d over dx of sine y. Now dx over dx cancels because they're the same thing. So then we are left with d over dx of sine of y equals 1. I switched the sides of the equation so that it's easier to see. Now we'll actually derive sine of y. And we know that the derivative of a sine is cosine. So then that gives us cosine of y. Remember, we are taking, this is very important, that since we're taking the derivative of y in terms of x, we're going to have to use the chain rule and say dy over dx equals 1. Now we'll divide both sides by cosine y to isolate dy over dx, which is what we're solving for. And then we're left with dy over dx equals 1 over the cosine of y. Now we're going to want to substitute cosine of y. So if you look at this right triangle, this original function over here, y equals arcsine of x, this actually means angle y has the trigonometric ratio of the opposite x and the hypotenuse 1. And as for this third side, we can solve using the Pythagorean theorem. So in this case, a squared equals 1 squared minus x squared, and then we take the square root of both sides and be left with a equals the square root of 1 minus x squared. Now we know that cosine of y is the cosine ratio of this angle y over here, this angle y. So what we can do is substitute that for y over 1, or I'm sorry, a over 1, which is just a. So therefore, dy over dx equals 1 divided by the square root of 1 minus x squared.
Thank you, Tomi. Now that you have seen how to find the derivative of arcsine of x, finding the other derivatives will be fairly easy as they are derived similarly. Now take a second to derive the functions by using these equations, and we will switch back to Tomi when you are ready.
Moving on now to the arc cosine of x. That's also going to be solved with being equal to y, and we'll go through the same procedure. Start by inverting it. X equals cosine of y. Taking the derivative of both sides implicitly, dx over dx equals d over dx of cosine y. There we go. And then that simplifies. That becomes d over dx cosine y equals 1. the derivative of cosine is negative sine, so then negative sine of y, don't forget the important chain rule, dy over dx equals 1. Then we'll divide by negative sine y, leaving us with dy over dx equals 1 divided by, negative 1 divided by the sine of y. Then we're going to use the same concept using the right triangle. That is y, that is a right angle. And this time it's a cosine, so angle y defined has the ratio x over 1, x being the adjacent, and y being the hypotenuse. And then making this time the opposite being a, we know that a squared equals 1 squared minus x squared. And therefore, take the square root, and a equals the square root of 1 minus x squared. Sine of y is opposite over hypotenuse, which is just a. So we can substitute that for a, and that gives us dy divided by dx equals negative 1 over the square root 1 minus x squared. Last one, arctangent of x. So this one is solved using, again, the same method. So this time I want you guys to try to figure this out. Try to find the derivative of arctangent of x. Just pause the video, and when you're done, resume the video. Okay, so hopefully you got it. This one's a little bit more tricky, so now I'll walk through it, see if you actually got the right answer. So same deal again from the beginning. We'll switch the x and y. X equals tangent of y. Take the derivative of both sides, dx over dx equals d over dx tangent of y. Then simplify, d over dx tangent y equals 1. And the derivative of tangent is secant squared. So the derivative becomes secant squared of y. And of course, don't forget chain rule, dy from dx. That equals 1. And then we're going to divide both sides by secant squared y, leaving us with dy over dx equals 1 divided by secant squared y. Put some parentheses around that. So just real quick, secant is the reciprocal of cosine. So that means secant is hypotenuse divided by adjacent. So noting that, we're going to have another right triangle, poorly drawn as always. Make that angle y, and it's tangent x over 1. So then we know that x is the opposite and the adjacent is 1, making the hypotenuse a. So then, therefore, a squared equals, is equal to x squared plus 1 squared, or abbreviated, that's x squared plus 1. And since the secant is already squared in the denominator, we can just substitute a squared for secant squared, and therefore we are left with dy over dx equals 1 over x squared plus 1. And there you go.
Thank you, Tomi. Here are some problems to consider deriving. Take a stab at them, and I shall explain them shortly. So f of x is equal to arcsine of x squared. This equation is fairly easy, as you just have to use a derivative of arcsine, which is this, and use a little bit of the old chain rule to figure out the derivative. So for the chain rule, use the garbage rule. For this, I would set x squared as the garbage, and take the derivative of arcsine garbage, which will equal this. Then we shall take the derivative of the garbage, which is x squared, so it is 2x. Multiply this into the previous equation, and voila! This is the derivative of arcsine of x squared. So here we set arcsine of x as garbage, and take the derivative of sine garbage. That would be cosine of garbage. Then we shall take the derivative of garbage, or arcsine of x, and multiply it to the previous derivative. The derivative of arcsine of x is shown here, so we can just add that to this equation, and there you go. The derivative of sine of arcsine of x. Now we know the derivatives of the inverse trig functions arcsine, arc, cosine, and arctangent as shown in this part of the video, and as well as how to derive them. Thank you for watching our video and have a nice day.